Welcome back, advanced topic students, to section 1.5, part 2. So in the first section, we learned about the different types of inequalities that we can experience for linear inequalities in one variable. We learned about the three different types of ways we can express it, set builder notation with using the inequality sign. It's very important that you keep in mind that this inequality sign, whoops, that's way too thick. This inequality sign can change direction, so you always have to be mindful of which way it's facing. There's not a set rule like on the left it's going to be the lower limit, on the right it's going to be upper limit. For interval notation, it's much better, in my opinion, just because it's always going to be the upper limit on the right, the lower limit on the left. And then the parentheses will indicate that you can't include that value, and brackets will indicate that you can include that value. And of course, we have graphs, which I think are awesome, very visual. So let's go ahead and apply this example that we just kind of reiterated there. So first it says, solve -2 times the quantity x plus 7 is less than 16 and graph the solution set. Now, anytime you're solving for inequalities, there's a big note that we got to keep in mind. Note, reminder, however you want to say it, star, okay? It's whenever you divide or multiply a negative to both sides, okay, you have to flip the sign. Okay, so just keep that in mind. You got to flip the sign, and let me highlight this, flip the sign if we multiply or divide by a negative number. So the first thing we're going to do here is we're going to solve this just like we would a normal equation with an equal sign, but this is an inequality, so we're just going to treat it just slightly different. So we have -2x minus 14 is less than 16 because we distribute the -2, and now we have a two-step equation trying to get x by itself. So I'm going to add 14 to both sides. Now, one thing you can keep in mind, notice how there's more than one ways to do certain things. So notice how we have a -2 being multiplied out in front here. Technically, you could have divided both sides by -2 first and then proceeded from there, but I'm just doing what most people do, what works most of the time, which is distribute the -2 first. So I distribute the -2, and now I'm getting the x by itself. So I get -2x is less than, and here we have 16 plus 14 is 30. Now we're going to divide by what? We are going to get the x by itself, so we're going to divide by a -2. This is your alarm here. We are flipping the sign. So in the next instance, we're going to have this going this way now. And we have x is greater than 30 divided by -2 is -15. Now we're ready to graph. So we're just going to plop on here -15. If you want, you can find 0, but it's really not necessary. So we have -15 plopped on here. We notice that it is a greater than sign. It's not greater than or equal to. So we know in the past we would have put an open circle, but since it is, we're kind of advancing, this is advanced topics after all, it's going to be either this or this. Okay, we need to pick one of these. Now, before we decide which one we should pick, we should kind of analyze this, and I like to put this into interval notation first. So in interval notation, interval form, we use parentheses. Now, in this form, we put on the left side, we put the lower limit, as I talked about earlier. So we put the lower on the left and the upper on the right. Okay, now I'm putting parentheses here, but they might change. We might want to bracket. So now, what is the lower limit? What is the smallest this can be? Well, if we're talking about all the values of x that are bigger than -15, that means -15 is going to be our lower limit. So this is our lower limit is -15. Put the comma. Okay, it can't get any smaller than -15. Now, how high can it get? Well, it doesn't say. There's no expressed upper limit, and whenever we have that instance, it's going to be infinity. And when we have infinity, we never use the bracket because it cannot be equal to infinity. So we're only going to use the parentheses. As we expressed here, you're never going to have a bracket equal to infinity because you just can't have a number equal to infinity. It's a concept. It's not a number. So look, we have our lower limit here. And this is good. If we have a lower limit, we're just going to copy this down exactly as we see it. We're going to put the parenthesis like this on our lower limit. Okay? And now the upper limit is infinity, so we're going to go into the right to go to infinity and beyond. as in the wise words of Mr. Lightyear, first name Buzz, would say. Okay, and that's what this graph will look like. Our lowest possible value is negative 15, and we go to infinity. Number 2, very similar problem. It says solve 14 plus 2x is less than or equal to 3x. I like this one because it has x on both sides. This is a common equation type that we need to solve. So the first thing we're going to do is I like to move the x's first. So we're just going to subtract 2x from both sides, and we get x is greater than or equal to 14. What do you know? That was a good old-fashioned one-stepper. So we have one step, and we're done with this one. What do we do from here? Well, let's kind of put it into our interval notation. We'd like to do that. So I'm going to put that in interval just so we can get an idea of what we're dealing with here. You know, we're going to have something left, we're going to have something right. Okay, and now we need to figure out what is our lower limit. Well, our lower limit, x cannot be any smaller than what number? Well, that's 14. Okay, x is greater than 14. There's nothing that can be smaller than that. So x is going to be 14. Now, keep in mind this. If x is bigger than 14, also note here that we have a less than, or excuse me, greater than or equal to sign. So it can't just be a parenthesis. It needs to be a bracket. And then we're going to put our lower limit here, 14, next to the bracket. That's our lower limit. What's our upper limit? What does x need to be smaller than? It doesn't say. There's no indicated value that x can be smaller, and this will often be the case when we have just one set of an inequality with two terms on either side, one the variable, one the number. And you can see here, this is what we call an infinite interval. That means it's going to have an arrow going in some direction, either right, left, or sometimes both, but most of the time it's going to be left or right. So there's going to be an infinite interval, which means we're going to have an infinity sign in here somewhere. Where? Well, that's our upper limit. And of course, it cannot be equal to it, so we put the parenthesis. So very similar to the other one, we're going to find 14. It doesn't matter where we put it. We're just going to say, okay, let's call this guy 14 right here. Okay. It's a bracket this time. There's our lower limit. And then we're going to go all the way to our upper limit, and it's an arrow because it is infinity. Also keep in mind, because we subtracted both sides by 2x, we don't flip the sign. It's only when we multiply or divide. All right, this one looks like it's a lot tougher than it actually is. Let's go ahead and kind of jump into it. This one might intimidate a lot of people, but I assure you it's not too bad. Now, take a look here. We have fraction here, fraction here, fraction here. This is fraction city. At first glance, we're like, oh my gosh, I'm going to have to find so many common denominators. Do not fear. What we're going to do instead is we're going to multiply both sides in every term by the least common denominator to get rid of the fractions. So we're going to look here at our friends in the bottom. Okay, our friend 3, 2, and 2. Anywhere we see a fraction, we're going to look for that, and we're going to say, okay, all right, hotshot. What is our least common denominator between 3 and 2? Well, that is 6. 3 goes into 6, 2 goes into 6, so we're going to multiply both sides by 6. What happens? Well, these two terms are being multiplied together, so we only need to multiply really by this front one. It's the same process, okay? Anytime you have two things multiplied together, you can just multiply by one of those things. So I'm going to choose to multiply the 6 by the 1/2. I'm also going to multiply the 6 by the 1/2 here, have to, because this is its own term separated by addition or subtraction. And then we have another term over here also being multiplied, so I'm going to apply this to the fraction out in front. Basically, I'm just multiplying the 6 by all the fractions. What happens? Well, I have negative 2 over 3. Let me actually use this in blue just to keep it a little bit more consistent for you. So we have negative 2 over 3. I'm going to give some space in there because I'm going to put that 6 right there. Minus 1/2. Give some space. Less than sign, 1/2, give some space, 5 minus x. Okay, now I'm going to move on to the 6. So I'm going to multiply this by 6. I'm going to multiply this term by 6. I'm going to multiply this term by 6. Now you can see really that distribution, and I'm going to try to avoid this guy. Let me just move him to the side. I know you guys can't move him on your notes if you have this same copy, but maybe you can just go around. Oh, you guys are smart. You'll figure something out. All right, now what am I going to do here? Now is when I cancel, and this is really where the true genius of multiplying by the least common denominator comes forth. What happens? 6 times this fraction. Well, the 6 is going to cancel with the 3 completely, but there's still going to be 2 left over. 6 divided by 3 is 2. I don't like that color. Don't like it. Doesn't stand out enough. Something more important. How about orange? Not loving it, but we're going to stick with it. So we cancel that out. Cancel the 6 with the 2. Okay, 6 divided by 2 is 3. We still have that 3 left over. Same deal here. And now we have a much easier equation. We have negative 2 times 2 is negative 4. And then we have this parenthesis x minus 3. Minus, we have 1 times 3. I'm just going to leave it like this just so you can see everything. I know 1 times 3 is 3, but just so you can see it. Less than. And if you want to do that in your head, that's fine. Then we have 1 times 3. I'm going to leave that 1 in there. 1, and then I'm going to put 5 minus x. So you can see it's really neat that we're able to get rid of all the fractions. It makes it way easier to deal with. And now we can distribute and treat this just like a normal multi-step equation. So here we're going to distribute. Here we're going to distribute. And so we have negative 4 times x is negative 4x plus 12. And of course we have minus 3 here. Okay, less than. And then we have 3 times 5 is 15. Minus 3x. Notice how this is much better than what it was before. Let's look for common terms. So we can go ahead and clean up this first. We're going to change that to 9. So 12 minus 3 is 9. But we still have this negative 4x plus 9 is less than 15 minus 3x. Anytime you have variables on both sides, it makes sense. It's more efficient to move the variables first. So we're going to move this 4x on over. So now we have, and no, why did I choose the negative 4x? Because it's smaller than negative 3x. Always move the smaller one, and generally that's the best strategy. So now we have 9 is less than, what color do I want to make this guy? I'll make them, so we'll say these guys combined. Okay, they combine those guys. Those guys canceled. So less than 15, what's that, plus x? No color, I use this color. Plus x. Then I'm going to subtract 15 of both sides. Notice how I'm subtracting. I'm not dividing or multiplying by a negative. So I get negative 6 is less than x. Okay. Well, we didn't get a lot of variety in these ones, but it's okay. We're going to put negative 6 on here. Now, if we were to put this in an interval term, hopefully by now you guys realize that the negative 6 is a lower limit, and there's going to be no upper limit, because it's not like something like this with 100 with an upper limit. If that's not the case, there's no lower limit, and of course it can't be parentheses. So we're going to put it like this, and then it goes to infinity. Okay, I think we have time for just one more example. Sorry those took a little bit. Now this is just kind of a little chart if you want to reference. I'm not going to talk about it really, but if you want to reference how these translate to word problems, you can kind of see some examples here. And we're just going to go over one of these examples. So if you want to follow the example, that's fine. If you want to look at the chart, study it, memorize it, look at it every night before you go to bed, that's all great. I'm not going to stop you from doing that, but take a look at example 4. Hopefully you can get the idea. So Martha has scores of 88, 86, 90 on her first 3 algebra tests. An average score of at least 90 will earn an A in the class. What possible scores on her 4th test will earn her an A? So let's assign the variable first. We have a variable here. It's going to be green. It says, what possible scores on her 4th test? So what is the variable? Her 4th test is going to be the variable. Let's call that x. So x equals her 4th test. Okay, now how do we find the average? The average is going to be equal to all her test scores, so all scores, sum, so all of them added together divided by the number of tests. Okay, so all of the scores sum divided by the number of tests is going to be equal to the average. We can go ahead and put in some information. Notice that we have right here an equal sign. That's going to change real soon because we have this phraseology here. I'm going to talk about that in a second. Scores an average score of at least 90. Okay, at least 90. That's important. So I want to put that there so you can see that's important. Okay, now all scores sum. So we have 88 is one score, plus 86 is another score, plus 90. Okay, and we have a fourth test plus x. Now we're going to divide this by, you guessed it, 4. There's 4 tests. Now this needs to be at least 90. Okay, I'm going to go ahead and put the 90 here in orange. So how do these compare? Is it going to be like this? Is this the way that we need to say at least 90? No. And you can even check up here if you want at least. Okay, that means it has to be 90 or bigger. So if it needs to be bigger than 90, then it's got to be that. And if it can be 90, at least 90 means it can be 90. Otherwise, it would have said greater than 90. We can put it like that. So it can be equal to 90, but it can also be bigger than 90. Now we're just ready to proceed here. It's not too complicated. This is just another multi-step equation. My suggestion is get rid of the fraction by multiplying both sides by 4. Okay, once we do that, we should have 360. Time to get my calculator out. So let's go over to my calculator. Okay, 88. I should be able to do this in my head, but you know what? Even math teachers need breaks. Okay, so right here we have 264 plus x, plus x is greater than or equal to 360. Notice how we already got rid of the 4. The 4 is canceled. Okay, now we just subtract 264 from both sides. And what are we going to get? 360 equals. We get 96. Whoops. Okay, x has got to be greater than or equal to 96. So this is actually super useful. I use this a lot in college when I had to figure out what kind of scores I needed to get. So this is super helpful, and hopefully you guys get an indication of how inequalities translate to word problems. Hope you enjoyed this video, and thank you for watching.